Now let's move on to question 2. So let's just compile this code, delete, and let's press F10. Okay, now I will execute. We will start to execute on line 9. So the first one, the value of X value will load to the register EAX. As we can see, it changed, and then negate, which means we make the value to negative. As we can see, the value of EAX now changed to negative value. And then for line 3, we load the value of Y value here, 30 decimal. We load to the our register EBX. So our EBX is this value, and then after I press F10, it will change to Y value. We load it, and then we substitute the value of EBX, our register right now, with Z value, which is 40 decimal. And then I press F10. We observe the EBX value, it will change to this value. And then for line 5, we add the value of EAX with EBX, and it will store in register EAX. As we can see, it changed to this value. And then for line 6, this is increment, so it will increase the value of EAX by 1, and after I press F10, it will increase by 1. And lastly, for line 7, we store the value of our register EAX into our operand R value. Our R value initially it is 0, and then we load the value of EAX, and then it will change to this value. Now let's move on to question number 4. So for question number 4, this is the operand that we have already declared. We have 3 operand, variable 1, variable 2, and also variable 4. So let's just take a look for our code here. So for line 1, we will start on line 1. So the value of variable 1 in decimal is 40 decimal. We will load to register AX. So let's just observe here our register AX. After we execute this line, it will change to this value. And then line number 2, we load the value of 5 decimal into register BX, and then we execute it, and our register BX changed to this value. So for line 3, this is multiplication for unsigned value. So we will multiply the value of AX and also BX, and then the result will be stored in register AX. And then we execute this line, and let's see here, the register of AX has changed the value to 00C at hexadecimal. And then for line 4, same like above, just load the value of variable 2 into our register BX, and then we observe our value of BX will change after this execution. Let's see. So this is the value after the execution for line 4. And then for line 5 here, we will subtract the value of BX by 3 in decimal, and then the value will be stored in BX. So here is our value. And lastly, for line 6, this is division. So for division, the quotient will be stored on register AX, and the remainder will be stored on DX. So let's observe our initial value of AX and also DX. So this is the initial value, and then after we executed this line, so we can see that the value of AX and also DX has changed to this value. So for AX, 001C is the quotient, and also for DX, 0004 in hexadecimal is the remainder for the division result. So lastly, for line 7, we will just store the value of AX here, 001C, into operand variable 4, which is the initial value is 00, and then after we execute it, it will change to 001C. Okay, now for the last question, which is question number 6. This is the full code for code snippet number 2. This is about division. So let's take a look on line number 9. So on line number 9, we load the value of 0 into the register DX. As we can see, after we execute this line, the value for register DX has changed to 0, 0, 0, 0. And then we load the value of 803 hexadecimal into register AX. We execute this line and it will change, the register AX will change to this value. Same goes for line 11, just move the value for 10 hexadecimal into register BL. So for line number 12, this is the division. AX we divide by BL. As we can see, AX is 2 byte and it will be divided by BL, which is 1 byte. So the quotient will be stored on AL and the remainder will be stored on AH. So we can see, we observe here the value of AX after we execute it, and we can see the value is 03 at 0, means that the quotient is 80 and the remainder is 03. And lastly, it is called random register. We just observe the final value for our register. So this is the final value for all the register after the execution.